So we've learned about vectors. Now let's look at adding vectors in 2 dimensions. We've seen how to add them in 1 dimension when they're collinear. Now we're going to look at adding them in 2 dimensions. And we're going to use the components to find the final value. So suppose I have 2 vectors like this. If I want to find their vector sum, I put them head to tail, and their sum should start at the tail of this vector and end at the tip of that vector, like so. Now if I ask you for the actual value of this vector, that's where you're going to start running into problems. Because adding these at when they're not collinear, you can't just add their values. You will not get the right magnitude, and you won't know anything about direction. So what do? Well, what we can do is actually use the components of the vectors and add the separate components. What do I mean by that? Well, let's take our resultant vector. We know this is our resultant vector, and it's the sum of the x component plus the y component. And where do those come from? Well, let's look at our original vectors. Here's my original vector, vector 1. Here's my second vector, vector 2. And if I want to find the distance in the x direction, I need to add this component with this component to get the resultant. So if I put them like this, vector 1 plus vector 2 will give me the resultant, which is vector 3, which is the sum of these two. And the other thing I can look at in the y direction, and I say, okay, let's do the same thing in the y direction. So the y component, vector 1 and vector 2, should give me this component of the resultant. So when we go to add vectors in 2 dimensions, what we're going to do is we're going to find what these values are, add them together to get these 2 components. Once I have the components of the resultant, I add the components together, and since they're at 90 degrees, I can use the Pythagorean theorem. Now, you're probably saying to yourself, hey, Wolfell, look, I can just add these using the cosine law, because I've learned the cosine law. And if I know the magnitude of these 2 vectors and this angle, I can find the resultant. And that's fine, you're right, you can do it with the cosine law. Where you run into some problems using the cosine law is when you're starting to add together a whole bunch of different vectors, or you're trying to do some vector operations. So for example, if I had something like this, where I have 5 different vectors, and I put them head to tail, now I could use the cosine law to find this one, and then use the cosine law to find the sum of this resultant plus that, and so on. It's going to be very long and tedious, lots of opportunity for a mistake. Using the components method will get me there a lot faster. And how does that work? Well, I just find all the components. I add this component to this component, to this component, to this component, and to this component, and I get the resultant component here in the x direction. Then I can look at all the y directions. I have my first component plus my second plus my third plus my fourth plus my fifth. If I add all those together, I'm going to get this component here. And when I add those 2 components together of the resultant, I'll get the final result here. So it looks kind of messy, and we're going to deal with it in a very formal way, in a very organized way in the next lesson.